All right, hey guys. So today what we're going to talk about is kind of an introduction to how to write in sort of the scientific style that you typically find in like science publications, journals, kind of different things like that. And so the page I have pulled up is actually what's called the Journal of the American Chemical Society. And it's a publication where they have lots of different articles on research that's being done out there by scientists. They have very recent kind of up and coming articles, and they also kind of go way back to different things that were done in the past. And so if you're going to take an interest in science, or especially someday do research or continue in the science field, then not only is it important to know how to kind of read and interpret these scientific writings, but it's also good to know how to write in the same style yourself. So if I go to an article here, it's actually about antifreeze, since it's kind of similar, to what we've been talking about, lowering the freezing point. And so what you'll notice about kind of each like science article is that there are certain similar components. Now it may vary a little bit from journal to journal, like how these components are organized, but one of the first things you'll always find is the title, kind of at the top, who worked on this particular piece, normally what like department or what research group or university they're connected with. And then you'll come to something important that's called the abstract. Now the abstract is kind of like the summary from the article. And so when, Google or the search engines or whatever are looking for something to kind of tag in the article, they normally tag the abstract. So that's how these articles are found. And plus, as researchers are looking for articles to kind of inform their work, they don't have time to sit down and read, 40 articles front to back. So what they'll normally do is just read the abstract, and that kind of lets them know if this is an article that they need to read, fully, or if they need to just keep moving on, okay? So what we're going to do is we're going to kind of start small and kind of walk through each of the different steps of the scientific writing. And so today what you'll do is you'll kind of follow along with the video, and you'll be kind of creating a science article or like a journal entry on the boiling point elevation lab that we did with like sodium chloride all the way up to aluminum chloride. Okay. And so what I'll do is I'll kind of take you through a little bit about each part of the science writing. Then I'd like you to pause the video and try to create your own part with respect to the boiling point elevation lab. And again, as always, please feel free to stop the video and ask me any questions you may have in person as well. All right, so let's start off with kind of just general formatting. And most of the way I'll teach this stuff is kind of by actually looking at some of the lab reports that I had to do my freshman year in college. And so the one I've got pulled up here is on freezing point depression. And this, I think, if I remember correctly, was the final lab report that I did my first semester in honors chemistry in college. And I had a lot of really good, lab instructors, and so I'm, thankful to kind of share what they taught me with you guys. So what I'd like you to do first is kind of note the formatting here at the top of the paper. So in just a second, if you'll press pause, and what I'd like you to do is to type the name of your lab in bold. So that would be boiling point elevation. Then you'll type your name. My last name was Leopard at the time. Then finally, you'll follow that by a semicolon, and then type your lab partner's name. Then finally, kind of the third line will be whatever section of the class. So that's just chemistry 2 for us. And then what we'll do is you'll type the date finally. Okay, so go ahead and press pause in the video and take care of formatting just your title, name, date, kind of all that good stuff. All right, welcome back. So now what we're going to move on to is what's called the abstract. I'm sorry, I didn't mean to highlight that whole thing there. Let me delete that. Okay. And so the abstract, again, is kind of like the first thing that your reader will see about your article. Okay. And so if you took pre-AP chemistry and had to write your own lab reports, this section is probably most similar to the purpose statement section. Okay. And so the abstract kind of serves a few main purposes. So one, it provides a brief overview of the main goal, of the experiment. And it also includes a little bit about the techniques that were used as well as the results. Okay. And so what I'm going to do is kind of show you a few sample abstracts that have been marked up here. Okay. And what I'd like you to focus in on are these comments to the side. So let me zoom in here. So the way your abstract starts off is you kind of have a summary of just the overall experiment. Then you'll kind of briefly, mention kind of the methods that were used. And finally, kind of summarize, whatever findings you had. So overall goal, briefly mention the method or technique that was used, and then kind of summarize the different findings. Now, as you're writing, kind of these things, you want to think about the importance of keywords. So if you think about a Twitter post, the keywords would be what you would put as hashtags, if this were posted on Twitter. And so it's kind of like the buzzwords, that other scientists or readers would be, interested in, okay? And so your goal is to keep your abstract concise so that it's easy to read, but complete, and that it contains kind of all the important words about technique, kind of different stuff like that. And so if I go back to the freezing point depression lab, I'll kind of highlight those different points of, mine. So I first start off with kind of just a brief mention of the goal of our experiment. We were trying to report a value for the molar mass of an unknown solute. Okay, so that's kind of the first part, is to summarize, your main goal. So for the boiling point lab, our main goal was to test the effect of the Van't Hoff I factor on the moles of a substance needed to raise the boiling point, okay, or elevate the boiling point. And so you'll notice kind of just in this first part, I go ahead and include kind of one of those key hashtag buzzwords, which is called cryoscopy. All right, and what that is, it's kind of a word that means you're determining the molar mass of an unknown, okay? So then what I do once I kind of get the general goal out there is I tell them the technique that we're going to use to achieve this goal. So I say we're doing this by measuring the colligative property of freezing point depression caused when the solute was dissolved in a solvent of pure cyclohexane. So this is the way we're going to do it, is by measuring the freezing point depression. Now notice, kind of here are the key words that I have within this section. I have colligative property, I have freezing point depression, and I'm also telling what solvent I'm using, cyclohexane. So these are kind of the hashtags or the buzzwords that I've included so far. Okay, so I've got my main goal, I've got a brief summary of the technique, or like the how we're going to do it, and then the rest of the kind of abstract kind of summarizes my results and my conclusion, if you will. Okay, and so I'll kind of highlight that last part for you here. So here's the last part, kind of summarizing the results. So I'll delete these other keywords right quick. Okay, so it says from the plotted cooling curves, we were able to calculate the freezing points of the pure cyclohexane in the solutions, which we found to be blah, 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 respectively. So there's my specific main results. So it says we were then able to use the freezing point constant of cyclohexane and the measured freezing point depression of the solution to calculate the molality, which in turn allowed us to calculate the average molar mass to be 149.8 grams per mole. Okay, so again, this is similar to some calculations that we've done in class, and I was just explaining there, what our results ended up being. Okay, so nice and short. If you'll notice, this is just, I think, 3 sentences. So 2 to 3 sentences, is just fine. You want to keep it short and sweet while still hitting on those key buzzwords. Okay, so now go ahead and kind of pause the video and write an abstract for our boiling point elevation lab. So remember, what you want to kind of do first is talk about the main goal of the experiment, then the technique, like by which you are going to accomplish that goal. Then finally, kind of summarize the main results of the experiment. Okay. Now, last thing, if you'll notice that all of this writing is in third person. So there's not like an I or a me or a you, but it's all in third person, and it's in the kind of past tense. So like if you notice, it says like we were able to calculate or we determined, so you're writing about something that you've done in the past, and you want to keep that in the third person. All right, so let's pause the video and give you a chance to write your abstract. Okay, so welcome back. All right, so now what we're going to do is typically after the abstract, there comes a section of the report that's called the introduction. Okay, and so what the introduction is good for is it informs your reader about kind of the science background, if you will, behind the experiment. So for example, in my kind of sample lab report, my introduction is kind of written about the science behind, freezing point depression. How does that work? What are some of the ways that this is applied in real life? So I kind of read through that together for you. So it says, in freezing point depression, a solute is added to a pure solvent in order to increase the entropy of the mixture, which decreases the Gibbs free energy and thereby lowers the freezing point of the pure solvent, which allows the solution to achieve lower temperatures before becoming a solid. This colligative property is applied in northern areas where temperatures are significantly lower during the winter, when salt is used as a road de-icer. The addition of salt lowers the freezing point of water, thereby reducing the formation of solid ice on the roads, which allows cars to travel with a lesser degree of risk. Within the United States, municipal governments spend a combined total of about $500 million per year in the purchase and application of salt for road de-icing purposes. Additionally, the use of salt as a de-icer can contribute to the corrosion of roadways, and the resulting runoff can cause contamination of groundwater and soil, thereby affecting the natural habitats of plants and aquatic life. Therefore, research is being performed on developing de-icers that are more economical and less harmful to the environment. One such solute is calcium chloride, CaCl2, which functions as a de-icer without the corrosive effects and sediment of buildup of salt. CaCl2 also has a lower freezing point depression constant than NaCl, thereby allowing it to facilitate the melting of snow and ice 8 times faster than salt, which requires 40% less de-icing material to be used. In this experiment, we were able to observe and calculate the freezing point depression resulting from the addition of the solute to the pure solvent cyclohexane, which has a large freezing point depression constant, thereby allowing its freezing point to be depressed more significantly. This provides further support for using solutes to lower the freezing point of solvents to allow them to remain a liquid at lower temperatures, as in road de-icing purposes. Okay. And so as you're reading through that, you're kind of like, wow, this actually is, not necessarily talking about the experiment itself, but kind of ways that this idea of freezing point depression, can be used in real life. And so the introduction, it kind of gives the science background on like the main topic, freezing point depression. And what it does is it tries to tie in that topic to kind of relevant, real life events or problems. And the idea is you want to justify, why is it important for us to be studying this, for us to be doing this experiment, for us to be researching this in the first place. And that's why you'll notice that this last sentence here says this provides further support for using solutes to lower the freezing point of solvents, blah, 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 as in road de-icing purposes. So what I was doing is trying to justify, why it was important for us to investigate this topic of, depressing the freezing point. And kind of my connection to the real world was that it can be used in, road de-icing applications. Okay. And so what I'm going to have you do now is kind of stop, pause, and write your introduction. Again, some things to think about as you write is keep it in the third person and then past tense. And your goals in the introduction are to provide a, kind of science background on your topic of boiling point elevation. And then, show your readers how this topic affects real life and therefore merits or deserves, investigation. Oops, scroll down there. Merits or deserves investigation. All right. Now, what you'll notice is kind of in the introduction when I'm, kind of pulling in these real life applications is that I'm using little superscripts to kind of cite my sources. And my sources I've included kind of in the footer. I've numbered them and I've cited them. I forget exactly what the name of this citation style is called. I guess I should have looked that up before I began, but I can kind of look that up for y'all and put that on Google Classroom, like how to specifically format, the sources that you go to kind of get some of this outside information. All right, so if you'll pause the video and write your introduction, then we're just going to cover one more part today before we're finished. All right. So here it is, last thing for today. So after the abstract and introduction are written, typically the next section of the report is what's called the experimental, okay? And so what the experimental does is it actually tells the readers of your report how you performed the experiment. So essentially this is your procedure, okay? And so you're familiar kind of with writing out your procedure, and you have to do that, in this boiling point lab. And so here are a few things that you want to, kind of keep in mind. Again, it's third person and past tense. So instead of saying, place the stirring bar in an ice bath on a stir plate, you'll notice we said a test tube with a stirring bar and 20 to 25 grams of cyclohexane was placed. So there's kind of your past tense. And the third person is when we're actually listing, the items themselves. A test tube was placed in an ice bath on top of a stir plate. Okay? And so you'll notice kind of a few things that are important to include is you want to include, specific equipment. So for example, they list they used a LabQuest. So specific equipment. You'll also want to include amounts of substances. So for example, they included that they used 20 to 25 grams of cyclohexane. And then the names of specific chemicals. So that's where you'll see like the name cyclohexane, blah, 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 kind of so on and so forth. Now your goal kind of in this is to break down your experiment in a very concise way that is still followable, that's still able to be followed by another scientist. So for example, when someone else reads this experimental, they should be able to go in and recreate the experiment, okay? Now, what you have to do to kind of, make this more concise, because otherwise this would go on forever, is you have to assume that the person reading your report, has a basic kind of science knowledge that allows them to maybe fill in, some of the gaps. So for example, where it says like a test tube with a stirring bar, is placed in an ice bath on top of a stir plate. So like a person with a general science background would know, how to work the stir plate. They would know how high to turn the stirring bar on. They would know how to clamp the test tube to something to hold it still, kind of all that good stuff. So that's why you don't have to include that, in your experimental. Okay, so I'm just going to read through kind of for you here and let you see this example, and then I'll stop and let you write your own. All right, and kind of last thing, you'll notice what I did just for formatting's sake is I kind of included like the title of each step of the procedure, if it had multiple steps, kind of in bold. So here we go. A test tube with a stirring bar and 20 to 25 grams of cyclohexane was placed in an ice bath on top of a stir plate. The Vernier LabQuest and temperature probe were set to collect time temperature data for 30-second intervals for a duration of 480 seconds. Data began to be collected when the temperature of the liquid reached 10 to 12 degrees and the temperature at which the solid first appeared was noted. All right, next part. The cyclohexane in the same test tube was allowed to return to room temperature, and approximately 0.4 to 0.5 grams of the unknown sample was added and dissolved. Approximately 1 gram of salt was added to the ice bath, and data collection was achieved in the same manner as for the pure cyclohexane. So again, that's a way to save time, saying that we did it the same way as before. Okay, and it says a second trial was performed by adding an additional 0.4 to 0.5 of the unknown sample to the room temperature cyclohexane. Approximately 4 grams of salt was added to the ice bath, and data collection was achieved in the same manner. And there you go. There's your experimental, short and sweet, but still specific and reproducible. All right. So we're going to pause the video now for kind of a final time and let you write your experimental for your boiling point elevation lab.